to talk about our plan for today. You do get to use Desmos on your test, on your STAR test. You won't need it today, though. We're not looking so much at the graphs. I want you to know where this stuff comes from in the equation. So I want you to look up at the top, okay? Exponential functions are in this form. A times b to the x. I want you to know, this will help with the word problems if you know about these. Your a value, the number in front that is not attached to the exponent, is your initial amount, also known as starting amount, also known as what? Initial value, yes. Your y-intercept. As long as the horizontal asymptote is 0, that number will be your y-intercept. Okay, it's the first number. It's not attached to the exponent. It's usually not in parentheses. Then the b value, this is what is attached to the parenthesis or to the exponent. It's typically in parentheses. That is your growth or decay rate.
Zero.
No. This is telling you how your values are changing. What is happening to them? It will be a pattern. They're going to be multiplied over and over and over by whatever that b value is. Okay, so if something's doubling, your b value is going to be 2. If something's being cut in half, your b value is going to be 1/2. Okay, if it's growing, I want you to know this, so write this down. If the b value is greater than 1, that means it's going to be growth. If the b value is greater than 1, then that means your graph will be growing. You would circle growth. If your b value is less than 1, then that means it will be 0.5 would be decay. Wow. 0.3 would be decay. Your b value will never be negative. Your b value will never be 0. Your b value will never be 1 exactly. It will always be something in between 0 and 1 or bigger than 1. But keep that in the back of your mind because that's really going to help you with some of our multiple choice problems from the STAR that I have at the end. Knowing like, hey, it's growing, so my b value's got to be bigger than 1 or vice versa, okay? And then your exponent is going to represent time. Now, if we're writing a function, x will stay as x. But in these word problems, a lot of times they're going to be giving us a specific time they want us to look at. In 5 years, how much money do you have? Okay, that sort of thing. So these first two were kind of a recap. This was just asking you to write the function and identify from that what your starting value is, whether it's growing or decaying. This is just kind of get your brain working here. What did y'all do with this table? Anytime you have a table.
I went to stat.
Stat. And then what do you do?
Edit.
Edit.
And then I
fill in the table. What goes in L1?
2.
Your X's. What goes in L2? Your Y's. Okay? Remember how to clear these lists. This is STAR review. Because again, the stat is something you probably are going to do like 10 times on the STAR test. Hopefully more because it's so easy. Okay? Clear, enter. Do not delete L1 and L2. If you accidentally delete L1 and L2, what do?
You add it back.
Second plus 712. If you ever do anything crazy on your calculator on the STAR test, no one can help you. No one can help you. So if you do something wild, like you accidentally delete that, just clear the calculator, start over.
What if my
calculator
gets corrupted?
It shouldn't.
What if it gets hacked?
It shouldn't. That won't happen either. Okay, all right. So you put your, L1, L2, okay? I'm not going to do the other one, but I'll do this first one. 2, 3, 4, 5, 6. Do you have to type all the numbers?
Yes.
Yes. Do you have to type them exactly as they are?
Yes.
Yes. Okay? So typos can cost you mistakes here, so make sure you don't have a typo. So put those in stat, and then what do we do after this?
You need to go to stat, calc, 0.
Stat, calc, 0. Now, why are we choosing 0?
Because we're doing exponentials.
Exponentials. STAR test, you may choose 4 if it's linear. You may choose 5 if it's quadratic. But everything for the next week or so, you're going to be choosing 0. If you can't find it, just scroll down and look for EXP. That stands for exponential regression. Press enter all the way through calculate, and then it's going to give you an A and a B, and that's going to help you write the function. So I would write the function y equals What's my A value?
16.
16. What's my B value? 1.5 to the what power?
X.
To the X. It reminds you at the top what it's supposed to look like, okay? If you don't remember. So, knowing that, this is my A. So, A represents our starting value. So, what is your starting value? 16. Now, technically, this is a y-intercept, so I could also write it 0, 16. Okay, that's a point on the graph. My growth or decay rate is my B value, which is what in this problem? 1.5. So, does that mean it's going to be growing or decaying?
Growing.
Why?
Because
Because 1.5 is greater than 1. Also, look at the y values. What are the y values doing? Getting bigger or smaller? They're not adding. That's the thing that makes it exponential. They're multiplying by 1.5 each time. Okay, watch. 36 times 1.5. What do you think it's going to be?
It's going to be
Should be 54. Times 1.5 should be 81. Times 1.5 should be 121.5. So that's how I can kind of confirm that's the pattern. I'm multiplying by that B value every single time. Okay? So what's the second equation? Second function? Anybody? Y equals?
Y
It's
equals
right,
20.
Parentheses 0.5 and then the X.
0.5 to the X.
Yes.
Okay? So was it growth or decay?
Okay.
Was decay. Why?
because it's 0.5.
Because it's 0.5 and that is less than 1. Also, your y values are decreasing. What was your initial value here? 20?
How do you write the growth rate?
No. Growth rate, you just put 0.5.
Sorry, like if it's decay or growth.
No, you just really circle. I'm just showing why it's growth or decay, but the answer is just like, is it growing or is it decaying?
Okay.
And then you could write this as an ordered pair. Okay? So what we're going to get into today, again, we need to know these facts. We need to know A represents our initial or our starting amount. We need to know that B is what we're growing or decaying by. But then we're going to be using these models to help us make predictions to find future amounts of stuff. So everything today is going to be a word problem. It's going to be a story. We're not really looking at the graphs today. That was last class. We're looking more at these stories, okay? And you need to be able to do a couple of things here. You need to be able to, number one, write the equation based off of the story, okay? You need to be able to interpret from an equation like number one. And then you also need to be able to make future predictions. A lot of this is done in your calculator. These are word problems, though. You do have to read, okay? So let's look at the first one. So since you guys are growing bacteria in biology right now, this kind of goes with it. Says the growth. What?
I accidentally touched it and I had
That's
to
gross.
put 20
Okay,
Infected.
doesn't matter. All right, the growth of the colony of bacteria is represented by this equation. So here's our equation. How do I know this equation is exponential?
because it's going up.
Because it tells you.
Because it has X.
Because it has x as a exponent. That's the key. Okay? So it says, what does the 105 represent? Well, here's my question. Is 105 an A value or a B value? If you were to label these, what would you say 105 is?
A.
A. How do you know it's A?
Because
it
it
says that up
says
there
it
in the
up
thing.
there.
Okay, specifically
And
why
it's
else?
before the parentheses.
Before the parentheses, is 105 attached to the exponent? No. So that's my A value, okay? Now, in a story, what does this represent? Your A is always your starting amount. So if there's 105 right there, how many bacteria am I starting with?
105.
Okay, so that's what it represents. So the starting, write this in,
Starting
amount of bacteria
Changing rate of bacteria.
is 105.
Fun fact, do you know that bacteria is in yogurt?
You are your
Grant.
We're not going to have a science lesson here. We just need to be able to interpret what that means.
Oh my God.
So that's always your starting amount.
Are there going to be questions like this?
Yes.
Grant, what are you talking about?
Yes.
Except for I have to write stuff.
Possibly. Okay. All right. Then it says, what does the 2 represent? Well, the 2 is our B. It's our base. It's in parentheses. It's attached to the exponent.
Yes.
Is that number greater than 1 or less than 1? Greater than 1. So are we growing or are we decaying?
We're exponentially growing.
We're growing. So this means that we are growing. The population is growing by a factor of 2. AKA, the population is doubling.
Factor of 2.
Doubling. Okay?
Yeah.
Pop?
The king of pop.
Population.
Oh. Okay.
The population is doubling. So if you see an equation, and again, sometimes your questions are like this. Here's an equation. What does it mean? You just got to know the front number is what you start with. The b value is what's happening to it. What if it was a 3? What if your b value was a 3? It's tripling. What if your b value was a 1/4?
Then it would be going up by
1/4 is decreasing by how much? It's being cut in what?
Wait, 1
Fourths.
Oh, 4.
Dang.
I thought you said like 1.4.
You get somebody.
Oh, no. No, like 1/4. Okay? All right, let's try number 2. We have to read. An initial population of 12 wolverines triples each year. That actually tells us all that we need to get an equation.
That's what Wolverine's gonna get the claw.
Using X for years and Y for the number of wolverines, write an equation that models the situation. How many will there be in 10 years? Okay, so we kind of got a lot to sort through. First thing, are we going to be growing or decaying?
Growing.
Okay, how do you know we're growing?
Because we're
Because it's tripling. Okay?
Well, we
What is our starting value? How many did we start with?
12.
12. That was in the problem. That's going to be our A. I would write A under there. Okay? Our growth rate. Well, what is the factor that we're growing by?
3.
3, because we are tripling. Okay, so that will be our B. So here's how we write our function. Y equals
12.
12, parentheses. What's our B?
3.
3
Close parentheses.
to the X. So if you ever write a function, you always need to keep X as the exponent.
What about after 10 years? Question mark.
Well, what does X typically represent? Look at the top.
Time.
Your time. So when we have a specific time, we are going to plug that number in for X. So we're going to type in our calculator. 12, parentheses, 3 to the 10th power. Write it down. Write it down like I just did. This is how you show me your work.
Wait, how do you do the 10th power?
70,800. Wait. Oh, 708,588.
Here's how you type this. 12, parentheses, 3, caret, 10.
I got it right. 708,500.
Oh, you just rolled that?
708, 588. What are we talking about?
Numbers.
Wolverines.
Wolverine.
Okay. So, would it make sense
Wolverine.
if you got a decimal, if you typed this function in the calculator and you got a decimal, and we're talking about the number of wolverines, would it make sense to have a decimal amount? No, so you kind of got to think about what your story's about. If you're talking about money, yeah, we can have decimals with money. Or like the amount of, I don't know, gas or something in your car, you can have decimals. But you have to have that conversation about, can I have a decimal or not? Do y'all remember the vocab word for that? This is a way throwback.
Oh, I don't know.
Throwback. Hold on.
Couldn't tell you.
If it's discrete. Do y'all remember that word, discrete?
I caught it.
Discrete means you can only have whole numbers. So people, animals, hats, that sort of thing, you can only have whole numbers, so you would have to round.
Hats.
Okay?
Animals.
You got a hat, animal hat.
I don't understand.
And his name?
Don't understand.
Oh, go ahead.
All right, flip over. It's technically the last new material in Algebra 1. This is the last new thing you're going to learn. Everything else from here on out is going to be review stuff until your STAR test, okay?
So what's the number?
April 23rd.
No,
Okay?
We're at Denver right now.
Also, if you're not going to be here on Monday, as some of y'all were saying, today's my last B-day with y'all. So let's do me a favor and be really, really nice
Oh, yeah, I messed this up
and
too.
pay attention
Oh,
to the end of my lesson, please. Okay? How about that? Let's stay focused.
It's just the last B-day, like the last day.
I'm planning to be here Monday, but a lot of y'all were saying y'all weren't going to be here Monday. So
I'm gonna be here just before you.
please do.
And after I'm going.
Okay. Okay. So the next page, again, we're keeping forward with this. Y equals A times B to the X. Go ahead and write that up here. But we have a slight variation with our B values if, and only if, you have a growth or decay rate that is a percentage. So circle this word right here. Okay, and why don't you draw a percent sign right there? So if you're reading your story and it tells you, oh, you're growing by a certain percent or decaying by a certain percent, only if you have this percent there, you have to have a slight variation on your B value, okay? If it says doubling, tripling, cut in half, cut in fourth, you don't have to do this. It's only if there's what symbol? Percent. So pay attention. Again, reading. It's going to be really important in these problems. A still represents your initial amount. That's not changing. X still represents your time. That's not changing. But again, that B value is going to change slightly. What's attached to the parentheses, depending on if you have a percent or not. So here's what these letters mean. Whatever that percentage is, we need to convert it to a decimal. So I'll show you how to do that. It's move the decimal twice to the left, divide by 100. It's not hard to do. But you have to change that percentage into a decimal form. And then if the problem says it is growing, you're going to add 1 plus that decimal. If the problem says it's decaying, you're going to do 1 minus. Okay? So kind of a lot to talk through. Let me show you some examples. They're really not too bad. So here's number 3. Peter pays $3,400 for a washer-dryer combo. Each year, the appliance loses 20% of its resale value. Okay? So we have some key words. It's losing value. So are we going to be growing or decaying? Decay. So go ahead and write that. Squeeze that in there. Then I see a percent problem right here. Immediately, my brain is saying percent. I need to change that to a decimal. So what is the percent exactly?
20.
Okay, here's how you change it. 20, type this in your calculator, divided by 100 is what?
0.2.
I want you to write R equals 0.2. I want you to write that down. Every single percent problem, take the number in front of the percent, divide it by 100. That is your R. Did you get that written down? Okay. So the first question, these questions are just to kind of help you think through it. They're not always going to be written like this. You're going to have to know. Says, what is the y-intercept? Remember, your y-intercept is the same thing as your initial amount, your starting amount. How much is his washer and dryer worth at first?
3,400.
3,400. Okay?
3 of them? That's not bad.
It's for a washer and dryer.
That's not bad.
Okay?
Did you just say 3 of them for a washer and dryer?
It represents the initial cost. Okay? That's how much his original set was worth. That's just the A value, if you want to label that A right there. What is the decay rate? Now, here's where we have to be careful. Our B values in percentage problems.
Wait, the 3,400 is A?
3,400 is A. It's what you paid originally. Okay? So it's decaying because it says it loses value. So this is going to be our B value. If it is losing value, our B is going to be equal to 1 minus R. We're losing value. 1 minus. What is our R value in this problem?
0.2.
1 minus 0.2. Can you tell me what 1 minus 0.2 is? Type that in.
Negative 0.2.
It's not negative, no.
It's 0.8.
Oh, 0.8.
1 minus 0.2 is, so your B value will be 0.8. Now, does that make sense that it would be decay?
Yeah.
Yeah, because is 0.8 bigger than 1 or less than 1?
Less.
Less than. So now that you have your A right here and your B right here, can you write a function? What would your function be?
It'll be.
Let's use f of x this time, just for fun. Just fancy.
You've already written it.
Fancy version.
It's the same thing as y, right? F of x.
Equals, what's going to be my first number?
3,400.
3,400. What's my B value?
0.8.
0.8 or 0.8. What's my exponent? X. So there's your function. So you just have to be careful. Your B value just needs a little bit more work if it's a percentage problem. Now the next question says find f of 7. That's why I use that function notation. What does that mean when they put f parentheses a number? What does that mean you do with that number? Roman, close your computer. Put it in for x. So this just means plug in 7 for x. So they may ask a question. They may say evaluate f of 7, or they may say how much is the washer dryer worth in 7 years. Either way, you are typing 3400 times 0.8 to the 7th power. Okay?
713 and 0.03.
Now, this is money.
Can it be my calculator?
You will need your calculator for sure. This is money. Money usually rounds to what decimal place?
The hundreds.
Make sure you put you did. The hundreds. So how much would we say the washer dryer's worth there?
$713
$713.03. That's our answer. Okay? So every single exponential word problem is going to be set up this way. Initial amount, what's happening to it, to the power of x, and x will be a time. We could ask just for the equation in stock, we could ask you to actually make a prediction giving you an x value to plug in. You just have to be careful if the word problem has a percentage in it. You have to go through that little change it to an r value. If it's growing, 1 plus. If it's decaying, 1 minus. So let's look at number 4 together, and then I'm going to let you try 5 and 6. Okay? All right. A growing farming conglomerate increases its water uses at a rate of 5% each year, and it initially uses 21,000 megaliters of water this year. Okay. So we got a lot going on. What is our y-intercept? What's our initial amount of water? 21,000. That's your A. Okay? This is our A. What does it represent? In the story,
Water used.
initial, make sure you always include that, initial water use. Okay? That should always be given to you. Okay? How much you start with. Somewhere in there. Now, you're done with 21,000. Don't use that again. Now, we need to know, is this problem growing or decaying?
Growing.
It is growing.
How do you know?
Because the number is above 1.
Well, you don't have a number yet. What does it say in the story?
Increases.
It increases. So our B value, because it's increasing by a percent, there's that percent sign. Do y'all see it? Percent, percent, percent. What are we going to do? 5 divided by 100. That's our R. So what's our R value?
0.05.
0.05. 0.05. Okay? So since it's increasing, when I actually go and write that growth factor, am I going to put 1 plus 0.5 or 1 minus? 1 plus 0.5, which is the same thing as,
Wait, I thought you said
you have to get these context clues from the story.
1, 0.
Okay? It will tell you whether it's growing or decaying. And y'all, I've seen multiple choice questions where they keep your function. I'm going to write this 2 ways. Where they'll write it like this. A times B to the X. I've also seen them write it like this. It's still A times B to the X, but they actually like write 1 plus 0.05.
Who would do such a thing?
you.
Mathematically, they're the same. You got to know either one. I would say most of the time they add it together, but sometimes they may have it separated out. But the key is you've got to know it's got to be 1 plus. Now, does it make sense that this is growing?
Yes.
Yeah.
Because what's your B value?
Higher than 1.
Bigger than 1. Not by much, but it is bigger than 1. So here's your equation. Y equals A times B to the X. Evaluate a F of 2, or another way, how much water will they use 2 years from now? Where do you plug in a 2?
52.5.
Where do you plug in a 2?
In the X.
All right, go. Type and don't blurt out your answer.
3,100.
I just said don't blurt out your answer.
Thanks, no, I'm gonna answer this.
I did not ask the answer.
You're bad.
21.
Bro, it's not the answer. Bro, what are you
Yeah,
doing?
copying her. Look, she's.
Yeah, but you're right.
I got the answer, guys.
Nobody in here.
We don't want it as
Yeah.
Did you know that my trap was so old I had to run out of the house when I had to play music?
So still the rules gonna follow me?
Oh, yeah, I seen that.
How do you memorize that?
Shout out to
So now we've done a percent with the decay, a percent with the growth. I want you guys to try 5 and 6, but I want to read number 5 real quick and make sure you understand the vocabulary. Okay?
Ed bought a new Mustang.
Ed bought a new Mustang for how much money?
$20,000.
$20,000.
That's cheap, isn't it?
Oh, excuse me.
Mustangs depreciate. Do we know what depreciate means?
Down.
They lose value. Okay?
I knew it.
What's a word that means they increase in value? That sounds kind of like that. Do y'all know?
Appreciate.
Appreciate.
Increase.
Appreciate. Or increase. But sometimes they may use words like appreciate or gain value. You just got to use your context clues. Okay, give me an answer to 5 and 6. See if you can. Everything is kind of in this format. Initial times your growth or decay rate to the specific time. You just have to be careful if you're growing or decaying by a percent. And they'll mix it, okay? You'll have some questions that there's percentages, some where there's not. We're about to go back to some that aren't. So here's Ed's Mustang. Again, depreciate means it's decaying. Some of you guys converted 22% to 0.22, which is right, but some of y'all did not do 1 minus in front of it. You have to do that, okay? You have to make sure that you remember to put the 1 minus. That is your B value. So here's your model. Here's your equation. It makes sense it's decaying. 0.78 is less than 1. And then make the prediction. This is money. You can keep both of the decimals there. Okay, did y'all get that one?
I did.
Okay. Number 6 was about student population. They gave you the original amount. They told you it was 25% growth. So with our B value, what did I put in front of my decimal, my R value? Because it was growing. I put a
Plus.
1 plus.
No.
Okay? If you didn't, 0.25 as an R value. If you didn't put 1 plus in front of that, would that give you a growth problem?
No.
If you just put 0.25 there, would that be a growth?
No.
That's why you have to go and put that 1 plus or 1 minus. Now it makes sense it's growing because it's bigger than 1. Now, this gave us this decimal, but we're talking about students. We're not going to have half a student, so that's why I just rounded up to 2813. 2000.
That is true. What if they
I-
have like different, like
we're going to have whole number people. Whole number people, whole number animals. Okay?
So, exactly what Miss McCartney said too, like, if I put that in and I get 1,500 students, that means I did something wrong. I probably did not add 1 to it. I probably just did 0.25. Yeah, because I know I should have more students, not less. Because it's a growing issue or problem on this one.
Okay? So the only time that we have to do that is when we have what kind of problems?
Percent.
Percents. Okay? So flip over real quick to the next page. I want to talk about 1 and 2. We'll take a little brain break, and then there's a couple more star problems that are pretty quick. Okay, 2 brain breaks in a day. Yes. Okay, read problem number 1. No, to yourself. Read to yourself.
Thank you.
In your head. In your head.
Debbie.
Which means not out loud.
He's being quiet though.
Oh, but this is easy.
Quiet.
Wait, do we have to, like, actually?
When you're done reading, I want you to look up, and I just want to talk about this problem real quick. When you're done reading the story, just look up. Is there a percent anywhere in this problem?
No.
So are you going to do any of this 1 plus or 1 minus stuff? No, because there's no percent. Now, here's something that this problem gives you right here. Does this freak you out if you see this equation?
No.
It shouldn't, because it's actually doing the work for you. Okay? So they sometimes do this on Star where they like set up the function for you. Does it make sense though? What's your A value according to the story? How many did you start with? 8,000. So that would be your A. Then it says, what's the pattern? It doubled. No percentage. So I don't have to do 1 plus anything. Doubling means it's multiplying by 2. That's your B value. So that's where they got that. They plugged it in for you. Okay? Cool. They already did it. What's the question say? How many bacteria will be present in 4 hours? Okay, what does it say hours is represented by?
128,000.
N. Okay? So all we have to do is plug in N equals 4. So our equation says 8,000 times 2 to the 4th power.
128,000.
You would, buddy.
Type that in.
Hold on, guys. I got to take this.
Oh wait, what?
And here's your answer.
Uh,
Oh no, it's 128.
Is this what our test will be?
There are sometimes questions where they already have it set up, but yes.
No, like just like this one.
Oh, so there's going to be 2 things on your test. One is going to be like key features. So here's a graph. What's the asymptote? What's the domain? What's the range? That sort of thing. And then the other one will be about writing. Writing and predicting. Okay?
What's a half-life?
We're going to get there in just a second. Okay? So if they give you an equation, I don't want that to like stress you out. It actually makes it easier. You do need to make sure you're reading and know like what the variables represent. Okay? But it's still that A times B to the X. No percent there. We don't have to worry about that there. Now, let's look at number 2. This is another type of problem that you can see. There's also a typo on here. Okay?
Oh dear.
So let's read it. Calcium 47 used for testing ancient bones has a half-life of 1 hour. Find the amount of a 100 milligram sample that's left after scratch out 24 and put 6.
6 hours.
Yeah.
What was that?
Okay. So then it asks, what's a half-life? So that is when you talk about like elements or something kind of like this. It's kind of a chemistry thing. But what that means is ever so often, in our case, every 1 hour, the amount that you start with cuts in half. And then the next hour, that cuts in half. So it's just saying that it's being cut in half in some amount of time. This calcium 47, that number 47 is nothing. Nothing to do with our problem. That's just the name. That's the name of what the scientists are working with. Don't let that throw you off. They do that a lot, okay? So, half-life, that immediately tells us our b-value. Is there a percent anywhere? No, so I don't have to worry about that. But my b-value means I'm being cut in half. So what is my b-value going to be? 0.5. If you ever see half-life, that means you're decaying. Your b-value is 0.5, 1/2, all the same thing.
Half hour of 1 hour, though.
So every 1 hour, it's being cut in half. How much do we start with?
47.
47 is not a number that we're going to use.
105.
105. Find the amount. This is our A value. And then we want to know after 6 hours. So what are we going to put in our calculator? 105. 0.5, because we're cutting in half.
Oh,
And then how long?
So
6.
6 times, because it's cut in half every hour. So if it's 6 hours later, that means it's been cut in half 6 times. 105 times 0.5 to the 6. And what'd y'all get?
I got 1.6406.
Let's do 1.64 mg. If you need to round, I feel like your answer choices will probably kind of tell you what to do there. So like I said, you've got to pay attention if it's a percent or not, because they'll kind of go back and forth, kind of like we did. All right, let's take, it's 10:01. At 10:05, we're going to come back to this and do some of these star questions. Few problems. So look at these. I think there's 5. They're all star. They're all star questions. And a lot of them, I think, are just setting the problem up, okay? But I want to talk about this first one with you and make you realize how easy some of these can be, okay? So let's look at this number 5. It says the amount of fertilizer in a landscaping company's warehouse decreases. You always want to circle that indicator, whether it's growing or decaying. That's important. It decreases by a rate of 3%. Immediately, percent. What do I need to do with that 3? Divide it by 100. So 0.03. That's immediately what I would do if I see a percent. Okay? Now, since it says it decreases, I would also write my B equals, am I going to do 1 plus or 1 minus?
1 minus.
Okay, I would go ahead and write that down. So this is my B value, 0.97. Okay? Roman, put your Chromebook up. We're doing this problem.
I'll go back around.
So I already have my B value. Then it says the amount of fertilizer in the warehouse was originally 78,000. Oh, I didn't even hear that. Okay? So what does that give you? 78,000 is your what?
A.
A. Okay?
A.
Which function models the amount of fertilizer? Okay, 2 answer choices we can knock off real quick. What has to be our front number in this problem? 78,000. So do A and B make sense? No.
Bye-bye.
Okay? We know we've got to start with 78,000. Now, answer choice C, our B value, 0.97. Does that mean it's decreasing?
Yes.
What about 1.03? What would that mean?
Increases.
That would be increasing. So does that match?
No.
So what has to be the answer?
Get him out of here. Get him out of here.
Okay, so a lot of these are really easy like that. All right, there's 4 more. Sorry, I couldn't fit them all. So there's 15, 36, 17, and I think 33. I want you to go through. Some of them have percentages, some of them don't. So pay attention when you have to do 1 plus or 1 minus. Try to do these real quick, and then we're going to go to Mathia. Work on star review. And then you two, we can try to do, I think we're going to have time. Okay? Answer these, and then you're going to go to Mathia. There's star review 2 and star review 3 are open. Did y'all do that Desmos thing? The transformations, Desmos?
This is great.
Yeah.
Okay.
And then we'll-
We're probably going to talk about that on Monday as well, because we
Didn't
didn't do
like them.
What do I put my decimal?